So let's start with the second part of linear regression. So decision tree builds regression or classification models in the form of tree structure. It breaks down a dataset into smaller and smaller subsets, while at the same time an associated decision tree is incrementally developed. So decision trees, if you see the picture, it is inverted tree. That is why it is the name given as tree. And you can draw your decisions from whatever outcomes are there. So decision tree regression, it can be used for classification as well as regression. In decision trees, at each level, we need to identify the splitting attributes. In case of regression, the ID3, that is iterative dichotomizer 3 algorithm, can be used to identify the splitting node by reducing standard deviation. In classification for information gain is used. Now a decision tree is built by partitioning the data into subsets containing instances with similar values, homogeneous. Standard deviation is used to calculate the homogeneity of a numeric sample. If the numeric sample is completely homogeneous, its standard deviation is 0. Now let's see the steps to find the linear regression. Calculate the standard deviation of target variables using below formula. As you can see, standard deviations formula. Then this is further by applying the various figures to that. Then split the data set on different attributes and calculate standard deviation for each branch. Standard deviation for target and predictor. This value is subtracted from the standard deviation before the split. The result is the standard deviation reduction. So this is how you can make it. And you can see the standard deviation also in this graph, which is shown in the picture here. Now this attribute with the largest standard deviation reduction is chosen as the splitting node. The data set is divided based on the values of the selected attribute. This process is run recursively on the non-leaf branches until all data is processed. So you can keep on doing it on a recursive basis. To avoid overfitting, coefficient of deviation is used which decides whether the stop branching is reached or not. So finally, the average of each branch is assigned to the related leaf of a leaf node. In regression, mean is taken where the classification mode of leaf node is taken. Now random forest regression, this is also an ensembled approach where we take into account the predictions of several decisions. That is regression trees. Select k random points, identify n where n is the number of decisions, regressors to be created. Repeat step 1 and 2 to create several regression trees. The average of each branch is assigned to leaf node in each decision tree. To predict output for a variable, the average of all the predictions of a decision trees are taken into consideration. Random forest prevents overfitting, which is common in decision trees, by creating random subsets of this feature and building smaller trees using these subsets. Now let's try and understand linear regression in Python with scikit-learn, sklearn. Now sklearn or scikit-learn is one of the most popular machine learning libraries for Python. This we have already learned in the earlier videos. As we know, the term linearity in algebra refers to a linear relationship between two or more variables. If we draw a relationship in a two-dimensional space between two variables, we get a straight line. Linear regression performs the task to predict a dependent variable value y based on a given independent variable x. So this regression technique finds out a linear relationship between x and y. Hence the name is linear regression. So if we plot the independent variable x on the x-axis and dependent variable y on the y-axis, linear regression gives us a straight line and the best fit the data point. So that is how you can draw a linear regression line. We know that the equation of a straight line is basically as depicted below. So you can see that and everybody must have seen these kinds of line graphs in so many cases. Now the equation of the above line is y is equal to mx plus b, which is a very standard equation, while b is the intercept and m is the slope of the line. So basically the linear regression along with algorithm gives us the most optimal value for the intercept and the slope in 2 dimensions. The y and x variables remain the same since they are the data features and cannot be changed. The values that we can control are the intercept, that is b, and slope m. There can be multiple straight lines depending upon the values of intercept and slope. Basically, what the linear regression algorithm does is to its multiple lines on the data point and returns the line that results in the least error. Now the same concept can be extended to cases where there are more than 2 variables. This is called multiple linear regression. For instance, consider a scenario where we have to predict the price of the house based upon its area, number of bedrooms, the average income of the people in the area, and other factors like age of the house and so on. In this case, we depend the dependent variable is dependent upon several independent variables. A regression model involving multiple variables can be represented as y is equal to b0 plus m1 b1 m2 b2, and like that you can go up to mn bn. Now this is equation of a hyperplane. Remember, a linear regression model in 2 dimensions is a straight line. In 3 dimensions it is plane, and in more than 3 dimensions it is hyperplane. So I think this concept you must have learned in your graduations. For 2 dimensions the linear regression graphs may be something as shown below. As you can see, the line is moving. Another example that can be explored is the aerial bombing operations of World War II data sets. Now this is the real data which is available on, if you go to Google and you search that, you will find this kind of a data set. In the D-Day landings were nearly postponed due to poor weather. Now that was the case during Second World War. We can use the weather reports data from that period to compare with missions in the bombing operations data set. Let us use weather data WW2 available as a CSV data file. So you can use this data set and which contains information on weather conditions recorded on each day at various weather stations around the world. Information includes precipitation, snowfall, temperature, wind speed, and whether the day included thunderstorms or other poor weather conditions. So this data we will be using in the next part, that is the third part of this linear regression. So we'll continue with that. Thank you.